Layer 10, you need to make sure you've got something to write with, something to write on. First little task, shouldn't take too long, less than 5 minutes. We're going to sketch and label a diagram. Okay, so pause the video until you've got stuff ready to go. Okay, so first job, you need to sketch and add labels to this diagram of a transverse wave. Okay, so sketch it and add some labels to it. So pause the video here, start your timer, start your song, and do that 5 minutes little quick task. Okay, so pause the video now. Okay, hopefully you've finished that little labelling exercise of this transverse wave. Here are the labels that I've added. We've got wavelength from the very top of the peak. Okay, from the very top of the peak to the next peak. Okay, it doesn't want to be halfway down the top of the peak there. It wants to be at the very centre, at the very top, the highest amplitude. Amplitude from the equilibrium line all the way to the highest point of the wave. Okay, and the same with the bottom amplitude from the equilibrium to the lowest point on the wave. If you've drawn your wavelength here, make sure it's where the wave crosses. Skip one and it's the next one because it's the same point on the next cycle of the wave that is the wavelength. Okay, if you wrote equilibrium as the distance here, give yourself half the mark because you could call that line the equilibrium as well as this, like it's the distance is the axis, but it's the equilibrium, the zero displacement line. Okay. Okay, so this week we are doing a summary of the atomic structure because we've finished the atomic structure unit. Okay, the triple scientists still have a little bit to cover. We need to do fission and fusion, some stuff on background radiation, and some of the extra uses of radiation. But apart from that, we have finished the atomic structure unit, so well done. Okay, so I'm just going to whiz through some of these ideas and then give you your task. So we've got, you need to know about the structure of the atom. So you need to know what the atom looks like, what our model of the atom that we use in GCSE physics is, with this idea that there's a nucleus with protons and neutrons, with electrons orbiting it in shells. You need to know the sizes. You need to know roughly that it's times 10 to the 10 meters. You need to know the protons are positive, neutrons are neutral, electrons are negative in charge. You need to know the mass of protons and neutrons and mass of electrons. You need to know how we found this out in terms of the absorption of electrons going to higher energy levels. Okay, we'll do that as a fun physics practical in September when we look at flame tests as a catch-up. But you need to know all about that structure of the atom, what it looks like, and how we know what it looks like. Okay. We also need to know about isotopes. It's a really common question asked is just define what an isotope is and be able to calculate the different numbers of protons, neutrons, and electrons just by being given the atomic symbol. So for helium here, it's the mass number is 4. That means it's got 4 nucleons, 4 protons and neutrons, so it's got 2 protons, 2 neutrons, because the atomic number is 2. The atomic number tells us the number of protons and the number of electrons. If the atomic number is 2, then if this isn't an ion, then it will also have 2 electrons. So to get the number of neutrons, we take the big number and we subtract the little number from it. Okay, you need to know the definition of what an isotope is. Then we need to know about the development of our atomic model. Okay, starting off with those tiny spheres with Democritus and working all the way up to this discovery of the neutron with Chadwick. Okay, pay particular note to the gold leaf experiment. This is the bit that comes off most often. Okay, this and the plum pudding model. So know what the plum pudding model is, know what the orbital model is, know how Rutherford, Geiger and Marsden came up with this new idea of the atom. Okay, how do they get away from the plum pudding model? Thinking about the direction of these alpha particles. Okay, so the alpha particles mostly going straight through tells it's mostly empty space. The ones that are high scattering angle, they almost come straight back. There's very few of those, but they do happen. They tell us that the nucleus is highly charged and it's concentrated. The mass is concentrated in the centre as a nucleus. Okay, you need to know the development of those models. That's really important. You also need to know about properties of radiation. So you need to know what the different types, alpha, beta and gamma, can penetrate through. So you need to know that alpha is stopped by paper, gamma has to be stopped by thick lead, aluminium stops, a few millimeters of aluminium will stop beta particles. You need to know that some atoms are unstable and will give out this radiation. We call that radioactive decay. You need to know that it's measured in becquerels. You need to know that we detect it with a Geiger-Müller tube. Okay, you need to know the different ionization values of alpha, beta, and gamma. You need to know and be able to use and rearrange. You need to be able to use nuclear equations to figure out the components of different decays. So you need to know that the top numbers should balance on either side. That 235 equals 231 plus 4. You need to be able to know that there's two different types of nuclear equations that you can come across, alpha and beta. Okay, the gamma radiation doesn't affect on its own the atomic number or the atomic mass, but beta and alpha K does. Okay, you need to know about half-life and about this really important graph where after every half-life the radiation, the activity will drop by 1/2 every time. You know it's a random process, but we can predict how long it will take for the radiation to drop in a certain amount of time. You need to know that definition of what half-life is. Okay, and then you'll be able to use that to calculate how old a sample is or how much sample might be left after a given amount of time. You need to know about the difference between contamination and irradiation. So irradiation, where the radiation goes into an object; contamination, where the radioactive source, the source of the radiation, is in contact with the object. Okay, so either you touching would be contamination, or the radiation, so the alpha, beta, or gamma, going through you. Okay, knowing the difference between those two things. Now, I've also going to attach this checklist, okay, with the different things that you need to know about atomic structure. So the first section is on the history of the atom, how that model changed, and the structure of the atom, so all the different bits of information that you need to know for your exam on the structure, about radioactivity, about activity and half-life, and irradiation and contamination. Now your job is you need to make a summary resource. You're going to make a mind map, a set of really good quality flashcards, some Cornell notes, a poster, a leaflet, a massive spider diagram, a revision poster, some kind of creative summary of the atomic structure unit. Now in it you want to have definitions. You would like to have sketches of certainly the half-life graph with some notes around it. You want to have a picture maybe like this showing the alpha, beta and gamma going through different materials. You want to have a picture of what the atom actually looks like labelled. Okay, you want to have diagrams and information about those models in the atomic structure. Okay, now use the checklist to help you add things to your summary. Okay, so once you've spent 15 minutes looking at something and doing some really good detailed notes on some definitions, go back, look at the checklist and think, oh, what do I need to put in next? Okay, keep your summary, okay, so you can use it in 10 months time when you're coming up to your exams, and take a picture of it and upload it to class chats. Okay, so this is the last bit of year 10 work that we are going to set. Okay, this is our last week. So those of you who've uploaded work every week, you've done absolutely brilliantly. Okay, I'm really pleased with my groups. The amount of work that's been submitted has been really good, and it's going to put you in a really good position for September when we start to do some catch up. Okay, some work to go around this. So we still need to look at doing some radiation experiments so you can actually see and understand what's happening and how they work. Okay, so it's bits that we'll go through as we go through our next units in September. But at the moment, okay, I'm really pleased with my year 10s. We're in a really good position. So well done. Okay, now I hope you all have a fantastic summer. I hope you all keep safe and well. Take care and goodbye.